Of the notes, we are looking at just some vocabulary on the difference between an ionic bond and a covalent bond. So there's no nomenclature, we're done with that. You've learned all of the different types of nomenclature. The last part of the year, from pretty much here on out, that nomenclature is going to be vital to your success. So if you are struggling with ionic bonds or covalent bonds or acids or anything like that, please make sure and see me and ask questions and make sure that you know how to do that, because we're going to take that nomenclature and then in the next unit we're going to use that to write out our chemical reactions. After we write out our chemical reactions, then we're going to take it and we're going to use math. So the nomenclature doesn't go away. It continues to keep coming back all year long until May. So that nomenclature is kind of the foundation of the rest of the semester. So if you're struggling, make sure and see me. Now, back to ionic versus covalent bonds. The first little bit of these notes, we're going to look at ionic bonds. And with your ionic bonds, remember you have a metal and a nonmetal. It's actually a cation and an anion. And with your cation versus your anion, what is actually happening here is your cation has extra electrons that it wants to get rid of. So like sodium has one valence electron. It doesn't want that one valence electron. It wants to get rid of it to have a full valence shell. You have something like an anion like iodine. With that iodine that you have, it has 7 valence electrons. It really wants one more for a full octet. So that electron actually gets transferred from the cation to the anion. And when it gets transferred from one to the other, you create a positive charge on your cation, a negative charge on your anion. Opposites attract, they stick together, and that's what creates that chemical bond. Now with your ionic bonds, they have some characteristics because you have a positive charge and a negative charge. The first characteristic is they are tightly packed together in a repeating pattern. When they come together, they make a crystal structure. So when they break, they can only break on the same lines. So if you look at table salt in a really small sense, like under a microscope, it's always going to be little cubes, no matter what. Because of the sodium and the chlorine, the way that they come together, they break along these planes, and it's always going to be in little cubes. Other crystal structures, which we're not really worried about the shapes for this class, that would be more like an AP Chem type thing, you have some different shapes as well. So if you have gemstones like a ruby or an emerald or a diamond, any of those things, you can only break along certain planes. That's because of their crystalline structure. So you can't have a heart-shaped emerald because it is emerald in shape down to that crystal lattice is what it's actually called. So with your crystalline structures, I just mentioned crystal lattices, you have your repeating patterns, and those repeating patterns are just called crystals or crystal lattices. All right, now if you have one formula of an ionic bond, it's called a formula unit. We already mentioned in the notes with the covalent, if you have one molecule, that means you have one covalent compound. So ionic bonds are called formula units, covalent bonds are called molecules. Now with your melting points and your boiling points, the melting point is the temperature at which something melts, the boiling point is the temperature at which something boils, so you're going through a phase change. They have super high melting points. It takes a lot of energy to break down those crystal structures. Same thing with the boiling points. It takes a lot of energy to break these things down and go from one state of matter to the other. So your ionic bonds have very high melting points, very high boiling points. They are also super strong in their structures. They're very hard to break apart. Again, when they do break, they break along those same planes, but it does take a lot of energy to actually break them down and crush them down. And that is in comparison to a covalent bond. Now your ionic bonds also in a solution, meaning you put it into water, it will conduct electricity. So an aqueous solution is just a solution that is made with water. Your aqueous solutions will always conduct electricity if they're ionic bonds. Another term for conducting electricity in a solution is called an electrolyte. So with your electrolytes, you have your Ionic bond, dissolved in water, pass electricity through it. If it travels through it, it's called an electrolyte. Electrolytes in like Gatorade or Powerade, those are just salts. They're just compounds that they add to it, and it has to do with the water balance in your system. That's also why if you drink too much of the Gatorade or something like that, you can actually dehydrate yourself. So electrolytes are necessary, but when you have too many, then it causes an issue, just like with anything. You can drink too much water and drown yourself. So yeah, you have all different things that happen there. Now, covalent bonds, when these two come together, instead of transferring an electron from one to the other, remember these share electrons. And when these share electrons, it creates a very weak bond because they don't have that positive charge, negative charge, opposites attract, they stick together. They're only sticking together because they are sharing those electrons. So they're pretty weak. They break down pretty easily. Most covalent bonds are not solids at room temperature. Most of them are liquids or gases. So when they are a solid, they are very weak in structure. They have very low melting points and low boiling points as well. Again, at room temperature, most of them are liquids and gases already. But in comparison to an ionic bond, a covalent bond will melt and boil at a very low temperature. They do not conduct electricity. So if you have sugar in water, it will not conduct electricity. In one of the demonstrations that you're going to see, I'm going to take pure water, H2O, and I'm going to try to electrocute it. And you're going to find out H2O, which is a covalent compound, doesn't conduct electricity because it's not an electrolyte. It doesn't have that positive and negative charge to conduct. Let me move this down a little bit. So I made this chart kind of comparing the two with your ionic bonds versus covalent bonds. So remember, your ionic bonds are made up of a cation and anion. Your covalent bonds are only made up of nonmetals. That isn't on here. It should be. I'll add that when I get done with this video. But these are only made up of nonmetals. Ionic bonds are called formula units. Covalent bonds are called molecules. Ionic bond transfer electrons from one to the other. Covalent bonds share electrons. Your ionic compounds are very strong. They're hard to break apart. Your covalent bonds are very weak. Ionic bonds have a crystalline structure. Covalent bonds do not. Ionic bonds have a very high melting point and boiling point. Covalent bonds do not. They're very low. Sorry, I said that wrong. And then your electrolytes are your ionic bonds. You have a positive and a negative charge. It gives something electricity to travel across. Because there's no positive and negative charges there, covalent bonds are not electrolytes. So you're going to see some questions on your test just describing some of these characteristics. It's nothing that you have an assignment for or anything like that today, but ionic bonds versus covalent bonds, you just need to know their properties of each one of them because we're going to keep going back to these throughout the year and throughout the semester for the rest of this unit. So I hope that makes sense. If you guys have any questions, be sure that you ask.